All right, let's dive in. Today, we're doing something really cool. We're going to build a personal AI assistant that runs completely 100% on your own computer. Forget the cloud. Forget API costs. This is all about pure, local AI power that you have total control over. Let's get to it.
And I mean really build it, from the ground up. Not just using someone else's service, but creating an AI that you own, that learns from your documents, and, this is the best part, keeps all of your information completely and totally private. That's exactly what we're going to walk through today, step by step.
So you might be asking, why bother? Well, the payoff is huge. First off, you get total privacy. Your documents, your questions, they never, ever leave your machine. Second, it's free to run. No more watching API bills climb every time you ask a question. Third, you can feed it your own custom knowledge, your work files, research papers, personal notes, you name it, making it an expert in your world. And maybe the most important thing, you'll be learning the foundational skills behind pretty much every modern AI assistant out there.
Okay, before we can start building, we've got to make sure our digital workshop has all the right tools laid out. Think of this as our pre-flight checklist to make sure you're ready for takeoff. So for this hands-on guide, we're going to assume you've got a few things already set up. You'll need Llama installed, which is our engine for running AI models locally, and we're assuming you've already downloaded two specific models, Llama 3.2 and MXPy Embed Large. You'll also need Python, the ChromaDB library to act as our AI's memory, VS Code Insiders as our code editor, and Git all set up. A GitHub Copilot Pro subscription is also going to be key here, as it gives us access to some powerful models right inside our editor.
So what exactly is this thing we're building? It's called a Retrieval Augmented Generation System, or RAG for short. Now, I know that sounds super complex, but the idea behind it is actually pretty simple and honestly quite elegant. Let's take a look at the blueprint.
This workflow here, this is the whole journey from question to answer. We start by preparing our data and then turn it into these numerical representations called embeddings. You can just think of them as unique digital fingerprints for every piece of text. We store all these fingerprints in a special vector database, which is kind of like a super smart library that's incredibly fast at finding similar fingerprints. So when you ask a question, we create a fingerprint for it, find the most relevant info in our library, and then hand both your question and .context to the AI to cook up a really smart, informed answer. It's a clean, logical flow.
All right, enough theory. It is time to get our hands dirty and assemble the toolkit. First things first, we need to get the actual AI models that are going to be the heart and soul of our system.
We need two key players on our team, and we've picked these because they're both powerful and small enough to run smoothly on most modern computers. Think of MXPy Embed Large as our super-fast librarian. Its only job is to create those digital fingerprints for searching. Then we have Llama 3.2, who is our brilliant writer. This is the model that takes all the information found by our librarian and crafts it into a fluent, human-like answer.
To get our librarian, you're just going to pop open your terminal and run this simple command. This tells Llama to go out and download the MXPy Embed Large model right onto your machine. Super easy.
And next up, you guessed it, we're doing the same thing for our writer. This command downloads Llama 3.2, the language model that's going to act as the brain of our whole operation. So remember, it's a two-part system. One model that's amazing at finding meaning, and another that's amazing at generating language. So with our AI models downloaded and ready to go, let's just do a final check on our development environment. We're using Python to glue everything together, a code editor like VS Code Insiders to work in, and Git to grab the project files. Once those are in place, your workshop is officially open for business.
Okay, the models are downloaded, our environment is set. Now for the really fun part, bringing our AI assistant to life. And believe it or not, it only takes a few final commands.
First up, we need the actual application code. This get clone command goes to GitHub and copies the entire project, which is called RAGFood, right onto your computer. This gives you the main script, the sample data, literally everything we need all in one shot.
Next, we just need to install the last couple of Python libraries. This one little command grabs ChromaDB, which is our specialized vector database for storing knowledge, and requests, which is just a handy tool our script uses to talk to the Llama AI engine.
And here it is, the moment of truth. Just navigate into that RAGFood directory you just downloaded and run this command. This single line kicks off the script, loads your data, fires up the AI models, and starts your very own private question answering system. It's alive!
And just like that, you did it.
Seriously, take a moment. This isn't just some simple script. You've built a complete, sophisticated AI system that's running right there on your desktop. You have a vector database, a local LLM server, and a full RAG pipeline. It just goes to show you the incredible power you now have right on your own machine.
So now what? You have this fully functional, totally private AI brain just sitting there, waiting for knowledge. The RAG Food project we used is all about food data, but you can swap that out for anything. Your work documents, your personal journals, your favorite books. The system is ready. The only question left is, what are you going to teach it first?